Alright, so let's save this out, and we're going to save this within a directory that we can get to. Let's call this Unit 4 on my desktop. And I'll save this as a TIFF. I really don't want any layer information. Displacement example. No compression. Same settings. Hit OK. So in Maya, what I want to do is just create a simple plane and make it a little bit bigger. It's 6 on the keyboard. Just drag it up past the grid a little bit. And let's go Window, Rendering Editors, Hypershade. Okay, let's go to Textures. Go to our desktop. Unit 4 texture. Click and drag it over. Double click on the displacement example. And this will bring up this thumbnail, and you can double click over it to generate a new thumbnail. Alright, next we create a new material like Lambert. Go back to textures, middle mouse button, click and drag this over to displacement map. Then middle mouse button, click and drag the Lambert over to the geometry. Let's rename this Lambert. Right click, rename it, and call it Disp. That way we know that this one is for displacement. That also means if I click on the map or the mesh, I should have Disp show up. Alright, so in order for this to work, we have to have more polygons. But we don't want to have more polygons because more polygons equals slow. Okay, so the idea of a displacement map is to tell Maya to calculate for a region, automatically up the resolution in that area, and then display the geometry based upon the black and white value of the map. Gray is 0. Okay, and that's something, you know, it's just a long-winded sentence to say, you know, there's a lot of math involved here when dealing with displacements, but Maya is doing all the work for you. So in order to tell it where to divide, we need a thing called Approximation. So here we have Approximation Editor. Now before we do this, let's make sure we turn on Mental Ray. So here I have a checkbox in Maya et More under Plugin Manager that states it's loaded. If you do not have that, please put it in and then hit close. Okay, then we go back to Mental Ray, Approximation Editor, and we're going to click on it, and we want the subdivision polygon sub-D surfaces. We're going to create one and then edit it. So there's a lot of different ways to divide a mesh. The most popular is parametric. The number of subdivisions, we're going to up this here in a little bit, but right now I'm just going to leave it maybe at 4. This is how many times the mesh will divide using the displacement map. Okay, now let's just by default go in and render this using, and I'm clicking this button right here. This is the render settings. Let's go into mental ray. Just leave everything alone and render it. And you can see that you get okay results right off the bat. But if you look, these are all dipped in, but there's nothing sticking out. Okay, everything's just dipping in, but nothing's sticking out. This is because of the calculation needed for the gray point of the map. Okay, so to calculate for that gray point, we need to go into the displacement, and this is under hypershade. Also, in case you're totally lost or totally can't get to that, you can click on displacement and click this box, and it will flatten out your network. Then you can go to the checkered, and under the checkered it's also connected to the displacement example. So you can see that I could switch between displacement example here or here using the tabs. Okay, down below we have a thing called color balance, and these are the numbers that we need to calculate for. Right now the alpha gain is set that 1, which is white, is too high. So what we need to do is normalize that to whatever gray value that we used. In this case, I know the gray value. It's 0.50. Okay. Again, if you want to calculate for other gray values, all you can do is go to your paintbrush tool in Photoshop, use Alt and click over the area, and then double click here. It will give you your black point or gray value. Okay, this is 50%. Let's say if I had a gray value that's over here, this is now 35%. So that's what, and that's how you can get your gray point. Okay, so if it's 50%, we have 0.5 for our alpha gain. Alpha offset is being calculated by alpha gain. In this case, if you take this number and divide it by 2 and put it negative, you will have your alpha offset. Let's not do that just yet and render it. Show you what happens. Okay, so it didn't do anything as far as the calculation of the high points is concerned. Okay, let's go in here and say negative, and half is what? 2.5 or 0.25. Alright, now it's showing a difference of change going the opposite way. And if we move our, oops, if we go like this and kind of tilt this way, you can now see that the area over here where we made the white is bumped up, and this is dipped in where it's black. You can also see that in Photoshop. Here's white and here's black. Alright, the jagginess is occurring because of the subdivision level. So if you go in and let's say at a higher level of subdivision, which is your approximation editor. Now getting to your approximation editor here is kind of hard. So what I usually do is just relaunch my window rendering editors, mental ray, approximation editor, make sure your mesh is highlighted, and then hit edit. That's probably by far the easiest way I found to get to it. Now let's up the subdivisions to 8. This will take a lot longer to calculate and render. So you can imagine if you're like working for a full-blown CG video that has tons of frames and you're using a displacement in order to generate geometry, it takes a long time per frame. And if it's 29.97 frames per second times each render, you can quickly see that it takes a lot of computing power to make that happen. So displacements are a Maya thing. It's a very rendering thing to do. Anytime that you're dealing with, like, let's say a game engine and displacements, it happens a little differently because the displacement has to happen in real time as you're walking around. But in a CG related thing, let's say like a Toy Story or any kind of Pixar video that uses displacement, you're thinking about, well, it's got to be lean enough to calculate per frame very quickly, so I'm not spending all day rendering each frame out. So it's a battle of how to get your frame down to the most efficient level of time. And you can see the results are really good, and that's not changing too much within the Maya construct. Alright. Now you can also see here that it's taking the geometry and it's subdividing it to the point where it's rounded at the corner because it needs to subdivide. And then you can actually brace the edge with an edge loop if you wanted to make it so it doesn't round it off. I think this is a very scripted displacement map that we've made here in order to show you how displacement works. So now I want to show you how to generate one based upon both texture and the value of a change between high and low on a mesh. So that's going to be in the next video.